First, welcome to the Precision Ag Technology Educational Conference. I'm Wes Porter from the University of Georgia. I'm going to moderate the session this afternoon, and so we've got kind of a little bit different session set up. So we've got two academic style speakers that'll talk. It'll be a little bit longer presentations, and then we're going to transition over to industry innovations and industry panel. And once we do that, what I'm going to do, instead of going back through all these slides again, they've kind of asked us to do that, but I've been told I don't ever really follow the rules anyway, so I'm only going to partially follow them today for time's sake. But we'll go to our industry speakers, and we've got about 5 industry speakers. We're going to give them their time. I think they've got about 15 or 20 minutes each. And then when they wrap up, when everyone has presented their talks, we're going to switch over to a panel discussion. And yes, I noticed there's no real way for an easy panel discussion, but we do have a wireless mic, and so it may go just as easy if you keep up as you're going. If you've got questions that you want to, you can ask questions obviously to the speakers at the time, but we want to open it up to a general panel discussion. And I see some of our speakers are spread amongst the room. Hey, you know what? If y'all spread like that, stay like that. That's fine with me. So if you want to jump in, I'll just make sure I carry the wireless mic out and back to everybody during the time, and maybe that'll help facilitate a little bit more interaction. So we'll see how that goes. So, Dr. Sherm, I'm going to turn it over to you. So Harold Sherm is professor, department head, interim co-director for IPA Institute. I don't know how, I feel like sometimes I don't know how to do it all, but then I look at somebody like him and I don't know how he does it all. So he's got a lot going on. Is a pointer and slide advancer right here. So it should work. Tested earlier, it's currently working. So Dr. Sherm, I'll turn it over to you.
All right, well, thank you and good afternoon, everybody. Wes mentioned the focus is going to be on industry contributions this afternoon to precision agriculture and specialty crops, but we thought it might be a good idea to kick it off with an overview presentation that looks at this space sort of from activities in the public sector, in other words, at research universities across the southeastern U.S. I tend to use a pretty broad definition of precision agriculture. The first bullet point here, so the application of advanced technologies, big data analytics, and models to improve the efficiency of the agricultural value chain through better decision making and increasingly site-specific and animal-specific operations. And so there's a couple of things that are important in this definition. One, it's more than just machinery, right? Advanced machinery. It also includes data and models. The other one is the value chain, right? So we are not just looking at production, but also at logistics and food processing and things of that nature. And then also, we tend to think about precision ag from a crop perspective, but there's also precision livestock management that's part of it. And, as you may know, at the University of Georgia in particular, we have a very strong precision poultry management team. And so I'm using this broad definition here of precision agriculture. That's different from a definition you might have used in the 1990s, for example. Different people in different universities use different terms for that. You've seen digital agriculture, smart farming, high-tech agriculture, e-agriculture, and then the brand name that we use in Georgia, Integrative Precision Agriculture, or IPA. In my mind, they are all synonyms and very similar, but of course you can find differences if you really want to. Now, why is precision ag a big deal for universities in the Southeast? In most of actually in all of our states, agriculture is a major sector of the economy. It's important to remain competitive. And so, from a farmer's or producer's perspective, the goal is really to improve production efficiency, reduce losses, and so forth through better decision-making and better technologies. From the university's perspective, precision agriculture is a high-impact research area that's sitting at the intersection between the agricultural sciences, engineering, and then data science and AI. And those are areas that most of our universities have invested in. And then, of course, at the state level, every state here in the Southeast is looking for, trying to attract technology companies, training their citizens, for workforce development with high-tech, in high-tech agriculture. So really from a state level, the goal is economic and workforce development and developing these public-private partnerships that everybody is looking for. And so precision agriculture is a really good, integrative discipline that allows us to do that. So I mentioned earlier, the brand name we have in Georgia is IPA, Integrative Precision Agriculture, Georgia's brand for digital farming, food, and fiber. And it's Georgia's brand, not just University of Georgia's brand, right? So it's something that stakeholders have, a term that stakeholders are using, as well as our elected officials, all the way up to the governor and so forth. And so in order to facilitate that, we have the Institute for Integrative Precision Agriculture, or IIPA, that is basically a collaborative hub to foster interdisciplinary research, education, and outreach on these next generation technologies in agriculture, food, and forestry. And so the collaboration is supposed to happen not only within the university, but also with external partners like, industry, for instance. And so although the IIPA has only been in place for about a year and a half, we already have 73 member faculty, which makes the IIPA actually the largest center or institute at UGA. And so these faculty span across 7 UGA schools and colleges. Really, the networking and team building is at the heart of IIPA. And so this slide lists some of the activities we've been engaged in over the past year and a half. So a lot of networking. We helped integrate new faculty members that were brought on board over the past couple of years as part of faculty cluster hires in IPA and in AI and data science, and try to connect these faculty members with existing research and other scientists across campus. Keep in mind, these people are in different buildings, different departments, different colleges, different schools, and so I think we need a glue that holds them all together and that provides a focus point for some of these activities. We've been able to give seed grant funding to a team of faculty members to jumpstart some projects, basically put them in a good position for grant applications, invest in collaborative equipment and infrastructure that can be shared across programs. I think some of you may have been at the International Integrative Precision Agriculture Conference that we put on in Athens in this past May. And then we're also co-sponsoring the 16th International Conference on Precision Agriculture in Kansas in July this year. So we'll have a strong presence there as well. Academically, we are coordinating the graduate certificate in agricultural data science, along with other things that centers and institutes do, like a seminar series and things of that nature. And then, as Wesley mentioned, my title is interim co-director, and so there is an effort underway to recruit to the University of Georgia an institute director that's more long-term, as well as an eminent scholar in integrative precision agriculture, and that's going a little slower than we would like, but that's what happens to be the case with these higher level type positions that are handled at the level of the Office of the Vice President for Research. I mentioned cluster hires at the University of Georgia in the area of integrative precision agriculture. And really, the people is our most important resource, right? No question about that. And so we've had a total of 4 cycles of faculty hires since 2020. And those 4 cycles brought a total of 15 new faculty members to the university in all kinds of different areas of expertise related to agriculture, precision agriculture, But if you look at these areas of expertise, I mean, I would say at least half are directly highly relevant to precision agriculture and specialty crops. So that's all I wanted to say about the IIPA. Other universities have initiatives that are similar. First and foremost, I guess I call it the sister institution, our sister university to the south, University of Florida. They have what they call AI Squared, which is the Artificial Intelligence Academic Initiative Center, which for them serves as a focal point for academic initiatives that are related to AI and data science. So it's obviously broader than just agriculture. So agriculture is just a small part of it, but it is a really important part of that. They also had a hiring initiative, so across the whole university, all different schools and colleges, they are planning to hire 100 new faculty in that space since 2020, which includes some in agriculture, plant breeding, things of that nature. They've had some industry donations or private sector donations to support computing infrastructure with that HyperGator supercomputer. And then, of course, they have AI initiatives that are academic in nature for students, like AI Across the Curriculum initiative, to basically infuse artificial intelligence and data science into all the majors and everything they do, as well as an AI Scholars Program to engage students. So those were two examples of higher level university initiatives in that space. And what I wanted to do now is shift to, I guess, the second part of my presentation, which focuses on some specific examples of what faculty members across these different research universities are doing. And so I guess I have a disclaimer here. Of course, I don't know everybody who's working in that field. And even if I did, it would be too much for a 30-minute presentation. Not everybody responded, some people did, and so it's really impossible to capture all the activities on precision ag work in fruits and vegetables. And if you think about it, 10 years ago, really, not many people talked about precision ag in fruits and vegetables, right? It was all agronomic crops pretty much, but that's, hopefully you'll see that that has changed in recent years and will continue to change with all these new hires. All right, let me start with the University of Georgia, and I'll start out with a new faculty member in the Department of Horticulture, Luan Oliveira. He is located at the Tifton campus. He's an extension specialist, and his title is Assistant Professor of Precision Horticulture, so he's really right in the middle of this. He started in August this year. He has a lot of ideas and plans, and some of them are listed here. He is interested in improving spray quality with spray drones and autonomous ground sprayers. He's also interested in improving the quality of mechanized operations in vegetables, for which there's a lot of room and scope. And that includes, among other things, mechanical transplanting for onions. He's also interested in remote sensing and machine learning applications for yield predictions in fruit and nut crops. And that's really important. One thing we learned at that International IPA conference in Athens last May from a peach producer is, for them the biggest deal is to be able to predict how much fruit are they going to have and when is it going to come off the tree. And so that's an important consideration as well as a number of other things that Luan is going to be working on. He's here in the audience, and in fact, he's going to give at least 2 talks during this conference, one in the blueberry session and another one there's another precision ag session on Saturday morning. This is another example. This is Dr. Guoyu Lu at the University of Georgia. He's basically a machine vision and robotics person in the College of Engineering. But for him, he's heavily involved in agricultural research, collaborating with some of our agricultural scientists on many different projects one of which that's been recently funded is the development of AI-based tools for disease detection in Vidalia onion. And among other things, it includes the development of a new smartphone app that would help identify onion diseases based on images that are taken with the phone, and then also development of a Scout robot, a small ground robot that would basically help map onion diseases in the field. Dr. Mahmoud, Sultan Mahmoud, is another new faculty member who started in August this past year. He's actually in my department, Department of Plant Pathology. His title is Assistant Professor of Precision Crop Protection. So what he's going to do mostly is develop tools and technologies for early identification of disease, improved spraying, as well as decision support models for disease. But he gave me a slide of a project that's currently ongoing that's focused on improving mechanical harvesting of onion, using at the specific steps in the harvesting process that cause bruising, and then finding ways of solving those problems to address those critical points. And he's also going to talk, I think, on Saturday morning as part of the other Precision Ag session that we have. And then the last example from UGA that I'm giving is Glenn Rains, who's also here. He's a professor of entomology at the Griffin campus, involved in precision ag efforts for many years, does quite a bit of work in agronomic crops, but also some in specialty crops like in blueberries. And the example he gave me is on peaches, where he's developed a system that uses UAV-based imaging to detect phony peach disease in peach orchards. And again, that was a collaborative project he did with plant pathologists. All right, switching to Auburn University, our neighbor to the west. So Auburn, does quite a bit of precision ag work, most of it really in agronomic crops. And, they do a lot of work in corn, cotton, and things like that. But I've got an example here from Steve Lee, who works a lot with spray drones, not only in specialty crops, but he has done some work in fruit trees, blueberries, and grapes to look at ways to optimize spray coverage with spray drones. Moving to Clemson University, this is an example, a weed science example of an unmanned ground vehicle that controls weeds in peach orchards, for example. And if you look to that, let me see. The picture on the lower left shows one of these ground robots that basically pulls a small cultivator for removing weeds in the row middle. And then it's linked to a machine vision system and a spot spray system that controls basically the weeds in, within the tree row. And the whole thing is tied up with a docking station and charging station, so it's almost autonomous. And then another example from Clemson University, a project actually funded by a USDA NIFA planning grant that looks at precision ag applications and implementation in organic vegetables. And so what they are doing right now is conduct a survey that looks at the current state of precision ag adoption and perceptions in organic vegetables, and that will be followed then by focus groups and some other activities later in the spring. So if you want to participate in that survey, there is a QR code to scan or contact me and I'll reach out to them. NC State University, this is an example from out of their biological and agricultural engineering program, a ground robot that assesses disease in tomatoes. And they found a really good correlation between what they measure with that autonomous robot and then what plant pathologists assess on the ground. an automated trap for corn earworm, which also is a pest in vegetables. So this is a collaboration at NC State between entomology and agricultural engineering. And so essentially what the trap does, it detects and counts these corn earworm insects as they enter, and then it's tied with a weather station that helps to develop a model to predict population dynamics of that particular insect pest. And then the last one is strictly from NC State, is strictly an extension example from Jason Ward. And this is essentially a series of 3 hands-on workshops for extension agents to train them in accessing and really working with various types of ag data sources. And so the 3 sessions have to do with satellite data, for the first one with yield data, and then also with weather data. So this is hands-on training for agricultural extension agents, which I think is a great idea in terms of them being able to handle these data. And then finally, last but not least, we have Florida, of course, a major specialty crop state. And so not surprisingly, there's a lot of activity at the University of Florida in that space. A lot of it is on strawberry and citrus, of course, but also on many vegetable crops. I got a couple of different examples here. One is Daniel Lee, who's a professor in Gainesville in their biological and ag engineering department. He has some examples mostly focused on strawberry, basically yield prediction based on counting flowers and fruit with machine vision, either from the ground or from a UAV. He's developing a smartphone app to identify and count two spotted spider mites in strawberries. And a couple more examples from him. He's developing a novel plant wetness sensor that's based on imaging. Many of you know that plant wetness, of course, or leaf wetness is a major factor in disease development. And so in order to develop disease models, you need to have a really good sensor, and the sensors we currently have for leaf wetness are not very good. And so hopefully that sensor will help us move forward in that space. And then also he's using imaging and machine learning for strawberry maturity assessment and bruise detection. And then this is the last one I have from Yanis Ampatzidis, who is at the Southwest Florida Research and Education Center. He's been doing research in precision ag applications for specialty crops for a number of years, which is why there's so much stuff on his slide that he sent me. But he's going to talk about that actually later in this session today. One example he has is the AgroView dashboard that basically integrates a lot of different data that's collected by UAVs and sensors and uses them for decision support. He's also working a lot on smart spraying. He's got a smart air blast sprayer that not only adjusts the spraying based on canopy volume and things like that, but also actually the sprayer collects data, counts trees and potentially fruit and things like that. He's also involved in machine development for spot spraying against weeds and vegetables like pepper and tomato. And then the last example he has on your right is an automatic system for trunk injection in citrus with antibiotics to combat citrus greening. So my conclusion from all that, and again, this is not necessarily comprehensive, includes everybody who's working on precision ag and fruits and vegetables, but my conclusion is there's lots of exciting research. Many of the people who work on this are new. Some of them are brand new. They may have been here half a year. And, many of the projects are really just getting started. And so I think the practical impacts in fruits and vegetables are still going to be a few years down the road. But I think the future is bright. So I wanted to thank everybody who contributed slides and then open it up for any kind of questions, depending on how much time we've got left, Wes.
We've got a couple minutes for questions. Thanks, Harold. Any questions?
Any questions or comments?
All right, if not, let's give Harold a round of applause. And as an appreciation, and all speakers will get these, but I'm going to go up one at a time, as an appreciation for you coming to speak. They had a little foresight and looked at the weather tomorrow. Hopefully it doesn't blow it out of your hand, but she had a nice umbrella. So up next is Chris Shimon, and Chris was with the the Georgia Department of Economic Development. So you're stuck in my head because I've known Chris through 3 different careers, and I would say the wrong one. That's not a bad thing. It's been a pleasure to work with him in all 3 different positions he's been in. So let's jump in. I had originally copied those moderator slides into yours, but I don't think we need to go through them again. Does anybody need to know what else we need to do? I don't think so. All right, we're just going to jump on ahead of that then. So with that, Chris, I'll go ahead and turn it over to you.
Well, thank you, Wes. And y'all probably all saying, what's a guy from the Department of Economic Development doing? One at an ag conference, specifically talking about precision ag. So I'll try to explain our role and what state government does to help the industry, and leave a few minutes for questions. So as Wes said, my name's Chris Shimon. I'm with the Georgia Department of Economic Development, specifically in a program called the Center of Innovation. I'll explain a little bit about that, but I always like starting with a nice photo. That's a drone shot from Pure Flavor, which is a controlled environment ag farm in middle Georgia. They're owned by Canadians, and they were our first kind of big controlled environment ag farm, and I'll talk about that as well as some precision ag stuff. So the obligatory slides from our department. So Georgia's been named the #1 state for business 10 years in a row. Most of those are metrics, jobs and investment is kind of the metrics that most economic development groups go by. So last year, over 38,000 new jobs, $24 billion in new investment just here in the state of Georgia. One unique thing about our department is, we are a state agency headquartered in Atlanta, but we have regional project managers scattered across the state. So they work with our local development authorities to help any existing agribusiness or regular business that's looking to expand. Most of that's around manufacturing and food processing. We also have a group that does nothing but international trade. They work a lot with the companies here in Savannah. So Georgia's one of the top exporting states, mainly because we have the port here. So Port of Savannah is one of the fastest growing ports in North America. And one unique thing is Savannah's the largest gateway for ag exports in North America. You can see here barely beating out LA and Long Beach, which are 2 big ones on the West Coast. Most of this is commodity ag, so cotton, peanuts, poultry. Savannah by far exports more poultry than any other port in the U.S. We also have a group within our department that's responsible for tourism. So has not really a lot to do with this session, but I always got to mention that tourism is also economic development. So is arts. We consider that as economic development as well. And something I know nothing about is film, but our film people, we've been the #1 state for feature-length production film, which is another little feather in the cap of the state of Georgia. I think 3 years in a row we've produced, or within the state of Georgia, more feature-length films have been shot than any other state. So what does our group do? The Center of Innovation, all of us take a little different approach to economic development. Most people in economic development or what I call more like Chamber of Commerce, their background, degree in English or international relations or something. Everyone on this slide has worked in industry, worked in academia. Most of us have masters. Just a lot of experience to try to drive these 6 strategic areas. So the 6 strategic areas we cover: aerospace, I cover ag technology. I don't have a picture of Steve. He's our newest guy. He was the COO of DFW Airport in Dallas-Fort Worth, so brings a lot of experience. Brian Weaver, our second newest guy here down in the corner, spent 22 years at Coca-Cola, opening and running plants all over the world. So I'm kind of the most inferior person, honestly, on this slide because everyone brings a wealth of knowledge. But our main role is to help small businesses within Georgia to grow and prosper and overcome hurdles. So hopefully everyone's seen this before. Who is not familiar with the University of Georgia Ag Snapshots publication? Hopefully everybody's seen this. So we go by this a lot in economic development when we're looking at new industries or our current industries trying to grow. So hopefully you know we're the #1 broiler producing state. We're the second largest cotton producing state, even though it's our largest of our row crops. We're the #1 peanut state. We're the #1 timber state. I don't know where we rank in beef, but it's 5th there total. So if you look at the most of what we produce in Georgia commodity-wise, we do a really good job in-state with attracting companies that can process those inside the state. When you get further down the list, it's kind of iffy if you're going to be able to either sell it here locally or process it locally. For instance, blueberries. At one point, there was an IQF facility that handled blueberries in Georgia. Now they no longer do. IQF is individual quick freeze. There's a huge demand that we hear from both producers and agribusinesses for more IQF. I've worked closely with the university talking about this, trying to get data. We've talked to companies, try to recruit them here. We haven't necessarily been successful yet on getting an IQF to handle more fruits and vegetables. But when we look at this data, we know that's a target because we know you need blueberries, you get further down, you get into sweet corn, things like that. We know there's a big demand for more processing here within the state. But what I really want to talk about is kind of how we help build this kind of ecosystem. Why is Georgia not only from a business standpoint the #1 state to do business, but ag is also our #1 industry. It has been the entire history of the state of Georgia, hopefully will always be the #1 industry. So part of it, and this is not an exhaustive slide, this is just a few logos I always just pick and choose. We can't do it alone. Our department, again, we are the specialists, you'd say, but there's only 15 of us out of 150 that have more technical backgrounds. So we rely heavily on our university partners. We partner with private industry. I see Lee here with Georgia Research Alliance, great partner in economic development on transforming, the knowledge based out of our universities into private sector jobs. So within my group, within Ag Technology, we kind of break it down into 4 buckets. So most of the companies we work with, most of the companies we're helping fit into kind of one of these 4 areas. And today we're mainly focusing on integrated precision ag, which is by far Georgia's been a leader. If you think about variable rate irrigation, some of the early drone work. I remember when I first got into economic development out of graduate school in 2012, our group, University of Georgia, Georgia Tech, and 2 of the commodity commissions did some of the very early work in like 09 and 10 in drones and ag. Drones in agriculture is a commonplace now. There's a lot of startups. We've worked with a lot of startups that are utilizing drones as a commercial service. But in 2009, that was kind of like, is this even going to work? What are we doing? So it was a lot of proof of concept work that was done just to kind of figure out what we could do with drones. Again, autonomous tractors, things like that. Controlled environment ag, as I mentioned, is probably our fastest growing subsector of ag in Georgia. So we went from 0 to 13 or 14 facilities total now in the state. And the last 2 here are more on the processing side. So the first 2 areas we focus on are more on the production side, and these last 2 are on processing. So food product innovation, something I think very relevant to this conference, is basically trying to transform commodities. So if you think about the true definition of a commodity is your crop is no different than your neighbor's. You're selling into a market that you have no pricing power at all. You're taking the price that the broker's going to give you, the grocery store, whoever you're selling to. So food product innovation, and a lot of this work is done at UGA through the Food PIC, Product Innovation and Commercialization Center, is trying to take those commodities, whether it's a waste commodity, whether it's your number 2 crop that you already harvested but it didn't make grade and you're going to throw it away, looking at just ways to add value, ways to actually make it a product that you set the price and you're not necessarily a price taker. This last bucket on the right, food system technology integration, a lot of that is the AI work and the automation around like poultry processing. A lot of that's going on at Georgia Tech. And so I got a few examples just of some companies in Georgia. So just to think about, because I interact on a good bit over the year, with farmers that say, hey, we got this idea. What can we do with this idea? Is there a commercial outlet for it? Is there a company that we can sell this idea to? So there's a few examples I'm going to go through. So Precision Ag, one, I don't know if you're familiar with Trellis, startup out of Peachtree Corners that utilizes some of the research that the University of Georgia had done over the year on soil sensors. Unfortunately, their founder passed away this past year, but the company's still pushing on. So most everyone's probably familiar. It's not necessarily new technology, it's just interesting that's here in our backyard. It's a lower cost cell phone app and a way to remotely monitor, mostly in row crops. They are doing some in the specialty crops as well. And I mentioned controlled environment ag. It's our fastest growing area. It's a unique area because I think at first, particularly a lot of the more traditional farmers I talk to, when they hear growing indoors, they immediately think it's a competition. So if you think of someone growing tomatoes year-round indoors, you're like, well, I grow tomatoes outside, spring and a fall crop. But what we've really seen with a lot of these companies is they're really complementary to our current system. So when we first kind of got into the controlled environment ag and talking with growers, talking with the university, 2015, 2016 timeframe, we did a conference called Aglanta. It was in Atlanta with us and the Southern Company, which is Georgia Power. The universities were involved. We invited a lot of companies to come. And it was really just to expose them to Georgia and show that Georgia is a potential place for controlled environment ag. So if I had this map created in 2015, it'd be 0 companies. The first small one was Better Fresh Farms in Metter, which is about an hour east of here, or west of here. And then Pure Flavors, the Canadian company, was the first large scale. And since then, we've just really seen the University of Georgia make a committed effort to invest. We had 1 faculty member when I first started talking with controlled environment ag. Now there's 5, potential more. Georgia Tech, being engineers, they wanted to get in on it as well. They have this, what's called the New Center, Nutrient, Energy, and Water is what New Center stands for. They're looking at it from the engineering standpoint on how to better manage nutrients, energy, and water within a controlled environment ag system. So to me, this is a really exciting area because you think about the opportunity for us to be leafy green producers in Georgia. 94% of the leafy greens come out of the Salinas and San Joaquin Valley on the West Coast. So basically, if you're eating a salad in Georgia, it's pretty much imported, we call it import. So that's really been our driver from an economic development standpoint is can we produce a Georgia-grown salad, like branded Georgia-grown, everything we know is local from local producers here in Georgia. And now with a lot of these companies that are doing leafy greens, that's something that we're seeing. And 2 quick examples around what is food product innovation. Innovation really is just transforming something, doing something different. So you may not think of cheese being innovative, but if you're a dairy farmer and then you get into making cheese, again, if you're a dairy farmer, you have no control over your price at all. So you're just taking whatever you can get. Once you make cheese, you can. So this is also an example I'll mention of what we can do with our grant program. So when Sweetgrass Dairy approached us, they were pretty well known in the Southeast, East Coast, looking at going to the West Coast, potentially exporting some down to the Caribbean. It's a higher end cheese. They were looking at more like the resorts in the Caribbean. Needed a shelf life study, needed some research done. We did this again with Food Pick in Griffin. But this is a unique example. We have the ability to do matching grants with companies. We partner with a private company and match their commitment, and that money goes to someone at a university to do the research to commercialize that product. So this one's pretty simple. It was more of, how long will this sit on the shelf? Are we doing our processes correctly? So it was a small grant. They paid half, we paid half. The university principal investigator researches it. Some of the others are more long-term. You get a grad student involved and really do some cutting-edge stuff. Last thing I'll mention is a good Georgia-based company I've worked with over the years down in Pelham, Max Manufacturing. They're an ag engineering firm, and they're really well known for making ice machines. I got involved with them with this poultry composter. They knew because of some of the EPA rules around emissions for incinerators on poultry that there was a more desire for looking at composting. Composting is nothing new. Humans have been doing composting for probably thousands of years, but utilizing automation, utilizing the newest steel type products, we were able to do this research grant with them to really help them generate data that they submitted to USDA so farmers could get the cost share through the REAP program. I don't know if y'all have heard of REAP. REAP's been around, Rural Energy for America program. A lot of row crop farmers have used REAP in the past to transition diesel irrigation to electric irrigation. That's really what it was known for. There was up to a 40% cost share for it, but this also qualifies if you're a poultry farmer. So anyway, there's a few minutes maybe for questions. Yeah. Kind of went through that fast, but that's why the government's involved in agriculture, if anyone's interested.
Any questions?
Any
for Chris?
questions? Either I was boring or everybody had a big lunch.
By the time we get to the panel, or something, you know.
Yeah.
Why does the composting, you said that's something that you guys working on, is the composting?
Yeah, so yeah, the questions is composting and how are we involved and what are we working on? So from our standpoint, again, our main mission is new jobs, new investment in the state. So the reason we were involved was he was an engineer. He had designed the composting machine, but from a biological sciences standpoint, didn't really have the data that USDA needed to say this qualifies for their cost share program. So we actually had the poultry science department involved in that to make sure that when you essentially you put dead chickens in it, mixed with poultry litter. You can put fruit waste in it. You can put anything in it. If you do it correctly, compost comes out in 7 to 10 days. So, and again, yeah, it sounds gross, and that was the main reason USDA didn't necessarily believe the data. They wanted to see it. They wanted an unbiased resource to look at it. So he sells those in different units, depending on how large. It's a single unit, depending on how large the poultry farm is. But the next phase we're looking at now is other waste systems. So if you think about in Atlanta, the World Congress Center, there may be 50,000 people there for a conference. Tons and tons, literally tons of food waste every day that you could easily run through something like this on site to get compost. So we were kind of engaged in those discussions pre-COVID. Those giant conferences honestly haven't come back like they used to have there. But that's kind of the next phase of equipment like that. But again, you can think about it, a packing shed. I know growing up working in watermelons, we just threw them in the back of a dump truck. When the dump truck filled up, we went and dumped it into the field. A composter would be a way to control it on site and not have to have somebody running back and forth to the field. So it's a unique thing, and it's a Georgia-based company that we're trying to promote. So.
Any questions? Yeah, any questions? Any other questions for Chris? Chris?
All right, thank y'all.
Appreciate it.
Appreciate it, Wes.
Thanks for that.
Thank
Yeah,
you.
Thank you. Appreciate that. All right. So when I pull this up, when it comes up next, we've got Giannis Ampantidis from University of Florida. He's an associate professor there, and he's going to discuss AgriView and AgSense for AI-enhanced precision orchard management. And tell me if I'm wrong, but this is actually a startup company that you're working on too. So we asked him to come on the industry innovations panel for the company he's working on, not necessarily exactly what he's doing at the University of Florida. So you got some University of Florida stuff a second ago, and now we're going to pull up some of the industry work that he's doing. So if y'all give me just a second, we'll get this up and ready to roll. And we're about 4 or 5 minutes ahead of schedule, but unless somebody just has a problem with that. See, that's what I figured. I knew somebody would be able to use them. I figured it would be all right. With it being a panel discussion, I feel like in the past we've kind of caught up and had time there. So this just saying it can't upload, and that's not a problem. And we do have our very last speaker of the day was unable to make it from Ag Technology, so we have that time slot open too. So I feel like we're good on time. So turn it over to you.
Thank you, sir. Hi, everyone. So yeah, today I'm going to wear 2 different hats. Actually, probably I will talk more about the spin-off company, but also I will show a few examples of what we are doing at the University of Florida. So let me start with the history of the company. So this is, we start the company, I'm a co-founder, back in 2020. And it was not a very good time to start the company because of the COVID, but we did our best. So you see here the timeline with some critical events. So we licensed a technology that my lab developed at the University of Florida. We call it AgriView. And then after that, we licensed another technology we call it AgroSense, and I'm going to talk about both of them. And the goal again is to commercialize and make them available to growers. I try to find different ways to offer this to our stakeholders, but it was very difficult to do it through the University of Florida, so that's why we started this company. And we are growing. And we have, as you see here, different, we got some funding from USDA to support the development of this further development of these technologies. And we have some key partners We work with crop insurance companies and, of course, specialty crop growers in Florida. So AgroView is the first cloud-based platform that runs a lot of artificial intelligence models and other models. It's a type of a software application, actually. Let's see what we can do. The main goal is to collect data and go down to the plant level. We heard before about site-specific management. Sometimes when we say site-specific, the site can be like a long area, large area. But now we try to see if we can collect data per plant. In this case today, I will focus more on tree crops, but we're working also with vegetables. So we try to collect data fast, quickly. We need to have accurate data, and then to be cost effective for our stakeholders in order to adopt. So this is, you see here an example of a citrus field, but again, this is the AgroView, the platform. It looks like this is an older version. We receive a lot of funding to develop that from USDA and other sources, and also a lot of awards. When you log in, this is an example of what you can see. This is a 2,000 acres of orchard, citrus field. So there are different blocks, and when you click any of them, you see some initial analytics in this window on your left. So the first thing, we count trees. So you know how many trees you have and how many gaps. With vegetables, we try to see if we can do it even for like the vegetable plants. And then you have some information about each tree, which I will describe soon. And then also we have the nutrient analysis for this field. When you click double click any of these blocks, or click here the view block, you are inside. So you can zoom in, zoom out, and what you see here with all these dots, they are the tree detections, and the blue dots represent gaps. And what you see here, you see a lot of gaps because in Florida, this is the effect actually of HLB in citrus industry in Florida. Growers had to remove all these trees because they are not productive or dead. So in this case, the grower wanted to replant, and he didn't know how many trees to order. He didn't know how many gaps he had. To count, you need to set people in the field, manually count the trees, the size of the tree, categorize them with clickers. Sometimes they drive the car and you have clickers, or the same for the gaps. It can take like months to do it and it will be very expensive. So we just went there, we flew. In few days, he had these maps. So you know exactly how many trees you have. We categorize them based on the height, the canopy volume. We have a health index and a leaf density index also. And we can detect also like problematic or dead trees. This is a video, the video demo. Again, this is a little bit older version of the system, but in the pie, you see the ratio between gaps and trees. And as you see in this case, we have sometimes 50-50. 50% of the area is like there are no trees. So it's not productive area. Again, it's very interactive. You can zoom in, zoom out. You can select or unselect the trees. In the histogram, based on the category that you choose here, for example, height, you see different height categories. We can change the bins from 2 to 9 now. Again, you see with the blue dots the gaps. Different colors represent different height categories. You can present only the gaps. You can select only to present 2 categories. You can, for example, select to visualize only the trees that are less than 10 feet tall. So this can help a manager to make decisions and understand what's happening in the field. And also we try to predict yield, and as I said also, we develop a fertility map. We also try to use this different USDA grant, and this is more like at the university level now. We try to see if we can use this tool and retrain this tool as a rapid response tool to extreme weather events. This is an example for the Hurricane Ian. This is the path through the Florida, part of the path. So what we try to do here, and I put everything in one slide because I don't have a lot of time, the green areas are the citrus production areas in Florida, in this area anyway. And then we have images for plains before the event, Hurricane Ian, and after. So we try to see if we can develop a tool to identify damages. And it can be a short-term damage, but it can be a long-term damage. If you have a flooded area, maybe after 5 months or 10 months, you see that some trees, they start dying. So this is still damage, right? So this is what we did, and also we try to see if we can detect right away, if we have pictures right away from drones or even from planes, fallen trees or flooded areas, things like that. And everything is automated, right? You upload the data. This is the beauty of this platform. You just upload the data and you don't have to do anything else. The system runs everything. It's not like you zoom in and manually you detect these points or the target, in this case, fallen trees. And this is an example of before and after image, the Hurricane Ian in this case, but we can use the same tool for other events. And as you can see with these blue dots, before and after, I mean, we have a problem with the resolution. We didn't collect the same resolution of the images, which is critical in this case, but still we are able to detect some changes. So the grower removed this tree, so we have gaps now. So yes, there's a potential to use this tool as a rapid response tool to extreme weather events, but we need to further investigate how we can properly do it. And then this is an example of fertility map. We use multispectral imaging and drones to develop this map. Again, this is for precision agriculture application. Different colors represent different, again, categories. I think here, what is selected? The nitrogen is selected, or potassium, I cannot see very well. And then this is the different colors, like different management zones for deficient, the red one, or low, to high or excess. So you can even develop fertility maps, and this is what we're, variable rate sprayers and fertilizers that they can read these maps and apply as needed based on every zone. And this is what we are developing right now. And also we have you can develop a report that you can see, like with some instructions based on the IFAS, University of Florida recommendations on what you can do in different zones. Again, the most important part of this platform is the data visualization. Not only visualization, we analyze the data. We take just images and convert them to information, practical information. In this case, it's also per plant, information for your every plant. So it's plant-based management. The other technology, AgroSense, I will go a little quickly on this one. Again, this is another patented application. We have a patent application for this one. It's an AI-based software technology. We can attach it to any farm vehicle, so it's a scouting tool, actually. In this case, and there's another company actually that licensed this technology to be used for precision spraying applications. So what we did, we put in a sprayer. Again, this is older version of this technology, but it gives you an idea. We have a LiDAR and 2 cameras, so we use sensor fusion, and then we try to detect the size of the tree, in this case, the volume of the canopy, the leaf density, and then at the same time we do that, we can control the number of the nozzles that we trigger, so it's more precise application. And also we detect and count trees, dead trees or alive trees. In this case, we have 3 categories. I think we have healthy tree, at risk, dead, and then also the gap, and also fruit. We cannot see all the fruit, but the information we can use also, we can identify events like fruit drop, and we have that because of HLB. Sometimes, like few months before the harvest, we see 30% of the fruits on the ground. If you go and drive all the time with your harvester, with your sprayer or the fertilizer spreader, you can even quantify these events, detect and quantify, and predict the yield. This is the graphical user interface. The important part here is that you can select and change the buffer, so you can spray a few feet before and after the canopy to cover the tree. And the other critical part is and this is a request from our growers, to have a tool to select to spray only on young trees or only on mature trees. So this is also some other things that we can do here. This is a video. As you can see, let me pause it for a minute to explain what you guys see. This is the camera, the stream from the right camera. The sensing system is somewhere here. So we count fruit at the same time we spray. And you see the location, the number of the fruit detected, the tree condition, and the tree height. We convert data to information. This is very, very critical here, and we save only the information. So you don't need everything, it's in real time. We run AI models in real time. If it's healthy tree, based on the height, you can trigger the number of nozzles that you need. And let me continue with the video. Here you see a gap. This is, there's no tree here, so you don't need to spray. So the system is able to recognize that, and you see the right part stop spraying. This is at risk. This is something that the old variable rate technologies don't have. They cannot detect leaf density. So based on that also you can change, for example, the speed of the fan, so you have better coverage. And this is two other videos. I will go quickly. So what you see here, and I think it's very difficult to see it in this video, but this is a dead tree, and it's able to detect even the dead tree and stop spraying. And here you see this is on-off because there are small trees. You don't need to spray continuously. That can save a lot of chemicals. And then here you see a pole, and it stops spraying. This is another novelty of this system. So the old systems that they have object detection sensor, whatever is the object will spray. A human will be there, will spray. With this system, it will detect, first of all, if the object is a tree, citrus tree. We found cases that it was a different type of tree and didn't spray, but at least it's a tree and spray on a tree. If it's a human or if it's another object, it will not spray. And then we developed this type of maps, which is very important. You just upload the information on AgroView, and you have a spray heat map and a fruit heat map. So if you click any of these points, which is the GPS locations, you see all this information: day, time, speed, flow, accumulated flow, number of fruit detected. So even the grower like that because, you know, you can even see where the application stopped. So the operator needs to go back and refill and start from this point. If they don't do that and you spray, let's say, for pests and diseases, if you don't spray in this area by mistake or something else, that can be a huge problem. So at least with a system like that can help the operator to know where it stops, so it doesn't need to stop and put flags everywhere to see, okay, where I need to continue, and also the manager. So there's a lot of things we try to do, and this is what we're working right now. We try to combine the fertility map from AgroView with the real-time sensing of AgroSense and improve the nutrient application, like fertility, to apply the fertilizers more efficiently. And again, we can read the maps, so we have different zones, but also real-time we see the trees, the size of the tree, and the leaf density, and based on that, we change the rate. We expect that we can even improve or save chemicals up to like even sometimes 40% or more. And I will not talk about that, but also we work a lot with early disease detection. We develop a novel technique, and it's we have another patent, provisional patent application to detect and differentiate different issues. In this case, can be diseases, but also disorders or nutrient deficiencies. Like in this case, it's an avocado. We have nitrogen, iron deficiency, healthy group, and a laurel wilt infected group. And we work a lot with tomatoes and different vegetables. And citrus is a little bit difficult to do it in Florida because the LCLB is everywhere, so it's very difficult to do that. And I will stop here. So I gave you a few examples of what we're working on. And we're more than happy to collaborate, so that's another reason why I'm here. So again, thank you so much. And I don't know, do we have any
Yeah, we got a couple minutes for questions.
time for questions?
Anybody have any questions for Giannis?
Yes.
All the algorithms running in the cloud, how's the data go on the tractor? Obviously, it's getting all uploaded, but you still have to manually enter all the fertility maps, and I'm assuming yield maps from the previous year, things like that.
Yeah, this is the only manual step that we have is like, let's say that you fly the drone. You need to take the data in a USB flash and upload it to the system, to AgroView. We have a tool, and believe me, that was a very difficult task to do because at the beginning, as a research tool, it was easy. Then when we start scaling it up and you come with thousands of gigabytes, the system stopped breaking and we have like several users, so we had to redo everything. This is a parenthesis, but you just put that and then just the raw images. You don't need any other software to stitch them together. AgroView will do it for you, and then we'll stitch them together as one more extra step is to create the perimeter of the field. And then after that runs all the models and the results is ready in a few hours or even less than that. Similarly with the sprayer or any other equipment, you need to take the data, but the beauty there is like, as I said before, we convert the data from the sprayer and the fertilizer. We're also working with a fertilizer spreader to information. We don't need to save huge 3D cloud LiDAR points or thousands of images because that will break the system. So we convert everything to information. It's a small file that you need to upload to AgroView, and then we'll visualize everything. And you have everything connected. And to your point, you're right. If you have a historical data, you can add them. So for example, some growers, we have different type of soil data also that we put it as different layers. So for them to do a better analysis to understand why they see differences in different areas, right? Okay, we create these management zones, but why? And for the fertility map, we produce it on AgroView using drones. Then you need to download it and then put it on the sprayer. This is what we are working right now, or the fertilizer. And you can do it wirelessly, or you can do it manually.
Any other questions?
Have you developed that apps only for that orchard crops or for another kind of crops like cabbages, lettuce?
Yeah, that's right now we offer this system for tree crops, yes, but we're working with vegetables too. The procedure takes time because if we develop something at the university, then the company license this technology takes some time, and then to commercialize it, we need to be sure that it works properly. But we are going to have different features for other crops too. But right now, citrus is the main crop, and we work with a lot of crop insurance companies also. But also we want to include different tree crops and of course vegetables. That's why I say, like, if you guys are interested in something, like, let's talk and see what we can do.
Any other questions?
Can you explain the cost, the cost effectiveness? You got $8 versus 15?
Yeah, so, and this is just a rough number, but to give you an idea, if you want just to go and count trees, and that was a requirement from USDA, especially for the crop insurance companies. The idea is like you want to insure something, you need to know the value of the property, right? It's a house, it's a car. So the same with the fields. So how many trees you have, how many productive, how many young. And the growers had to, a lot of growers anyway, not all the growers, had to do that manually. They had to hire people, and they go with clickers, like maybe in a truck. One looks left, one the other right, and they click when they see big tree, another clicker when you see a medium size, a gap. If you ask me to do that, I will make a lot of mistakes after like a few minutes, right? I mean, it's impossible almost, but it was very time consuming, it's super expensive. We try to estimate the cost doing that with the cost just flying a drone. The main cost comes from flying a drone because especially if we need to go to different locations, we don't fly. We have collaborators to do that. I'm talking about the company. The name of the company, by the way, I didn't want to mention, but it's Agriculture Intelligence that licenses technology. So we work with a lot of pilots, and they fly. So they ask for $3 to $5 per acre, plus the cost of the software to use. It goes up to, and it depends what services I mean, if we work, it's an annual agreement. So if we fly more times, it might be more, but it's per acre basis. Not per flight, it depends, that's why I say. After a point, all the flights are covered by the company.
So it'd just be one flight to do that tree count?
If it's just the tree count, usually it's one, but if you want to use fertility or even you want to update your inventory every other year or something like that, they ask for more flights. And now we try, by the way, this is my last one, I promise I stop. We try to use, again, we are using planes, but we try to see if we can use satellite imaging, and the problem there is the resolution. If you want to collect data per plant, you need a really high resolution, up to like sometimes 10 to 20 centimeter resolution. The satellites, they give you 10 by 10 meters, 1 by 1 meter in a good case scenario, which might be very expensive though. So we work with different satellite companies or companies that develop sensors for satellites, and we develop unique techniques to enhance the resolution, using also artificial intelligence to enhance the resolution of these images from satellites so we can use it. Oh, this is my time?
No, somebody in the back got that.
I'm sorry.
Maybe they are trying.
I know, but I know I can talk forever. But yeah, I can follow up with you later if there are more questions.
I'll get it in a minute. Y'all good. Giannis, thank you.
Thank you, sir.
Give me a round of applause. And we're not cutting. Remember, we'll turn into a panel discussion at the end. I'm not trying to discourage questions. I'm glad they're happening now. But, you know, if there's further discussion that needs to happen, you know, and we need to table it because of time to move through, let's do that and keep those at the end because we want to move them through it. So there's your gift. Appreciate it.
Thank you, sir.
Now, up next is Walter Cromer. He's the founder of Eden Concepts, and he's going to discuss a revolutionary autonomous planter for vegetable crops. So Walter, give me just a moment. I'm going to get you pulled up here and ready to go. And we'll see if we can get yeah, there you go. We'll get our lights straightened out here in a minute. We got to find somewhere in between, right? We'll get there. We'll get there. There it is. Actually might have control behind you too. There you go. You want the notes.
I don't need it. Well, I'll use them. Well, good afternoon, everybody. Thanks for your time today.
Give me just a minute. I'm gonna play with them up here.
Okay.
Hold on, Glenn. Hold on. I got preset right here. Let's find one that's good. You like that one? That one's pretty good, ain't it?
As I said, I'm Walter Cromer, and it's a pleasure to be with you today and talk a little bit about what our company's doing. It's precision germinated seeding. It's a new system for growers. Our company was founded in 2018 by my wife and I, and we are in Knoxville, Tennessee. Earlier in my career, I was an agricultural research engineer with the University of Georgia in Tifton, and I moved to Knoxville. Thought I'd be there 2 years, moved back to Atlanta like all my buddies, and I ended up in Knoxville for 34 years. In 2018, I'd had enough of my career in IT and decided to go back into ag engineering, and I love it. I grew up on a dairy in Middle Georgia in Monroe County. I understand how hard it is to be a farmer, and I learned how to work hard there. So I always had a passion for agriculture, so we started off on this company, and it's been a wonderful thing. At Eden, we're changing the way the world plants its commercial vegetables, and that's what I want to talk to you about today, the work we've been doing as a startup company. It's a radical change in the process. It's called precision germinated seeding, and decades of plant science went into this. They determined that it was a valuable process to germinate your seeds in advance and then plant them in the soil. 22 crops at least were studied and found to have higher yields and better performance doing this. But there's never any engineering done to create the planters that could plant these wet growing seeds. And that's where we came in. We decided the technology had advanced. As we all know, we can do things on these things that when I was a research engineer, I'd start a program at 5 o'clock in Tifton, and next morning I'd find out it had finished one slide, okay? So things have really progressed. No mystery to this, people attending this conference, that labor is a huge problem in agriculture. We all know that. The headlines aren't getting any better. Government's not helping much by raising minimum wages and requiring overtime in various places. So the vegetable business, of course, is very labor intensive. So are flowers and specialty crops. The primary value of our solution, as we'll get into it, is the labor savings. We see startups delivering technologies to do harvesting, to do weeding, and at some point there'll be a convergence where we'll have everything, the whole system completed, so there will be much less labor going into it. Currently what we see and have studied is simply the research and the development work is going into improving mechanical transplanters, but they don't fit on all farms. There's not a one size fits all, and they're very expensive. This is a different technology entirely, and that's what I want to talk to you more about. But it's not just the cost and the availability of labor, it's the quality. I talked to a grower in Georgia here who was telling me about sending a guy on a tractor down the road to a field to spray his crop, and he'd be down there in a few minutes and check on him, and by the time the guy got there to check on him, he'd gone in the wrong field and destroyed $70,000 worth of crop. it's the quality as well. So whether we solve the availability and the cost, who's going to train them and get them to stay there? A farmer in Arizona told me as soon as he gets them in, gets them trained, they get into the U.S., they're off to San Diego to do something else. So it's a long-term problem. How big is the problem? The top 5 transplanted vegetable crops in the U.S. grow on about 840,000 acres according to the latest vegetable census from USDA, which was in 21. At a minimum, that's $250 million a year in transplanting costs. And that's if you're doing automatic transplanting or let's call it semi-automatic transplanting. California growers tell me they put 6 people on a semi-automatic transplanter. So our solution is to do something different. We're going to germinate seeds on the farm and plant them with an autonomous precision planter. When we talked to the original plant science researchers in the United Kingdom that started working on this and asked them why was this never successful, they said one of the biggest problems was there was no reliable way to germinate seeds on the farm. People were trying to do it themselves. But then once you've got that planter, you've got to get that wet seed in the ground. So we'll talk about that more in a minute. Our system, we project the labor, because it's autonomous, is 96% less than a semi-automatic transplanter. The fossil fuel use on the farm in the planting process is near zero now because it's all electric. It's also a much lighter weight system. So it can get in the field when the field's a little too wet for your traditional transplanters or in your tractors. But we estimate 76% lighter weight, so the soil health will be better because of the lower compaction that you'll experience with this system. So how does it work? It's a 2-stage system. You have a stationary device, typically in your barn or in another farm structure, connected to water and electricity. We call that the germination system. It will then produce a batch of germinated seeds, and I actually have some right up here. They're not actually germinated yet. They didn't go through the germination system. I just brought them in for demonstration today. But you'll transfer that batch over to the planter, which will be an autonomous vehicle. Sometimes in a larger acreage might be operating in a swarm environment where multiple systems are communicating and planting an entire field. As I mentioned, this is all based on decades of plant science research. So let's talk about the steps. Step 1, in the barn, we've got a farmer with a wireless device like an iPad or a phone communicating with the germination system. It's connected to electricity and water. They enter the crop they want to grow, the variety, the desired planting date, the row spacing and the acreage, the germination rate of the seed batch, and some other pertinent information. And then the system calculates how much seed is needed and gives them some other information, figures out from a protocol that we've already established and downloaded into the device how long it will take to germinate these seeds properly into a batch that can be planted effectively. And then it takes over. It loads in the required amount of seed from the hopper on the device, adds the water, manages the whole process once you press go, notifies you of how it's going, and you can inquire of it how it's going. And if you decide you don't want to plant on that date, plant scientists tell us we can put these seeds into plants into cold storage on the device and hold them for up to 6 days. Step 2 is, once they're ready to go, you transfer them into the planter. You tell the planter, again, with a wireless device, the crop, the variety, the soil type, maybe the slope, the mulch type, plastic, no-till, the plant and row spacing. I personally sat underneath a pecan tree in Monroe County, Georgia, and adjusted the row spacing on a John Deere row planter with 9/16 and half-inch wrenches my life as a teenager. I know it's hard. I don't like doing it. So I've told us we're going to put this thing, you're going to tell it how wide the row width is, and it's going to adjust that automatically. Okay? In California, contract planters go from one field to the next, and they have to spend the night with their teams adjusting their planter widths, because the farmers don't plant on the same width in processing tomatoes for some reason that I don't understand. You load everything in, you move it out to the field, you align it to your starting point and give it some information about your field. It guides itself along the beds and with precision plants these seeds into the ground, constantly sending you alerts and notifying you of anything that might be going wrong. and allowing you to interrupt the process remotely if you need to. Follow up and finish, it can do some things like assess the crop, return it to the field a few days later. Maybe the tomatoes are going to be up out of the soil in 3 days. Send it out there on the 4th day, let it run the whole field, and tell you where all the skips are. Come back, tell the germination system how many seeds are needed to fill those skips, create those seeds, germinate those seeds, load them in the planter, go back to those precise spots and plant them. If you had a washout, this rain we've had this week, go back and fill in a washout. It can clean itself up, run an automatic sanitizing process after every planting so you don't spread disease, and then store itself for the season after it does that. Of course, as you can imagine, there's a few key technical challenges to it, trying to do this. We've been working on it a while. One of them, as I mentioned, is germinating seed batches on the farm in an optimal approach. Having a nice distribution of radicals that aren't too long so they don't clog the planter, but not too short so that when they hit the soil, you're getting a nice stand in an optimal period of time. You've got to handle growing wet, delicate seeds. An audience like this that I've spoken to has often had trouble understanding why you can't take these seeds and put them into a standard monosem or other kind of planter, dry seed planter. It's simply because this is what they look like. They're in a gel, which we'll talk about more in a second. It's wet, it's growing, it has a radical. If it touches a valve, anything like that, and breaks that radical, that's over. It's over for that seed. So we had to have a way to handle it. Then we got to ensure there's one seed only planted from a random batch. Is that my time? Oh, okay. Ensure one seed only planted from a random batch. So let's say you got 50,000 seeds in the barrel, so to speak. I like to describe this way. Your children want some chocolate chip cookies. They don't want, Pillsbury. They want from scratch. Make them in the kitchen, mom or dad. You mix them all up for them, and they're excited as they can be, and you got that one child, just that one child who walks in and says, I know you can do it, Dad, but I just want one chocolate chip in every cookie. And you got a batch mixed up with chocolate chips all through it, randomly dispersed. How are you going to get them out? That's what we're up against. Getting one chocolate chip, one seed out in the soil every time. Only one and always one. And then putting it down precisely so that it gets optimal growth. Quite a few challenges. We've been blessed by the National Science Foundation, the USDA, Launch Tennessee, and the Autodesk Foundation with grant funding that allowed us to make progress. We've selected a cushioning material for seed transport. It wasn't too hard to find. We ended up with what the plant scientists used. One of the things they use, this is Laponite RD. It's 2% Laponite in tap water. It's non-OMRI certified, but it's non-toxic. Matter of fact, it's in this room with us right now. It's on these walls. It's what they put in paint to keep it from sloshing like Tom Sawyer did when they did whitewashing the fence. It keeps the paint from sliding off the wall until it dries. It's most likely in some cosmetic or pharmaceutical that you've used in the past year. It is a modifier that causes something to change the way it flows. And so we use that. It is a synthetic clay, so it doesn't have to be mined or imported from another country. It can be manufactured. It's cost effective. And as I said, it's a clay. It actually has atoms on it that theoretically might actually help plant growth. That has to be studied, not by us. We're a bunch of engineers. So we have figured that out. We've proven a low-cost seed sensing and flow control capability, and proven a low-cost ability to segment the single seeds from the random batch, and the ability to singulate these seeds out of the machine. We have a U.S. patent pending, and we've applied for more funding from the USDA. We have a great team, but as you can imagine, mostly technical. My wife and I, she's a software engineer, great retiree from University of Tennessee. Dr. Wilkerson's a sensors and controls guy, and Jason and Joel are great mechatronics and systems guys with a wealth of experience in multiple major companies and universities, and a total of 18 patents We also have a great set of advisors from a business side to plant science to marketing and product development. Our ask is really, I'm a startup company, so we always end with an ask, okay? Our ask is, how can you help us? Will you help us? We want to get feedback. We've talked to a lot of growers about to validate the problem exists. What we now want to talk about is, does the process, does the approach work? And how can we make sure that we as engineers design the product that meets the needs appropriately and solves a real problem? It takes money, so anything you can do to help us find funding, that would be appreciated. We need to funding to scale our pilot systems to field units. We need to field test, so if you're interested in running a small field test, we'd love to talk to you. And then we need to find people who want to become early adopters or can help us find people who want to be early adopters. Because we've got to get people out there to understand this radical new approach works. And then we can begin to change how the world plants its commercial vegetables, flowers, and specialty crops. Thank you for your time today. On behalf of our team, I want to thank you. And thank you, Wes.
Any questions for Walter?
I got one. Have you thought about if you need to put plant pollinators in a row with your regular crop? Have you thought about being able to differentiate that seed while it's planting?
So I'm not sure I understand the question. Did you say pollinators?
So if you're planting,
Go back up, can you
for
go back?
example, watermelons, and you plant a certain amount of your seedless watermelons, and you have to plant the pollinator in there.
Oh.
You can't grow, and so it's a different type of seed every fourth or third plant. Have you thought about being able to switch seeds back and forth while you're going down the road?
Have not thought about it. That's why you're here and why we're talking. My quick answer is I don't know, but I'm pretty sure that's a software change. Okay.
Any other questions?
What sizes or ranges of seeds have you been using for carrot seeds, potato seeds? How big are we talking?
Believe it or not, the plant scientists went all the way back to begonias, petunias, okay? Little bitty stuff. But we looked at we're looking at what's our beachhead market, where do we go to first, what is the largest crop? It's fresh market tomatoes. It's actually processing tomatoes, but that's a really hard market to get into. So fresh market tomatoes. So all of our research to date is on tomato seed, okay? Pepper seeds are basically, most of them are about the same size and actually have the same geometry and color even. So the two of those, they're actually number one and number two. We've actually been approached about can this work with Pima cotton, which would not grow in the southeast, but the California Pima cotton growers are asking us, they're saying if this works, we can grow more Pima cotton further north in California, and that's a really high value crop.
I got a question on the cost, what the cost benefits are.
So, we're still pretty early, so we pricing goes into that. How much is the unit going to cost you? And I'm not really prepared to share a price because it's all hypothetical at this point. But it's also really difficult to come up with what the current cost is. So we use the cost budgets, for example, for the University of Georgia for growing fresh market field-grown tomatoes. Ran that number out, took what our current pricing is, and we think we save you 67% of your planting cost. Okay? California, we say, Florida, we save a little less because I think their labor cost estimate was a little higher on their crop estimate or crop budget tools. In California, it's just a whole different thing. They're growing thousands of acres of processing tomatoes.
Well, you said there were plant health and yield benefits. What does that data look like?
So there were a lot of papers, and I don't have it committed to memory. I'm sorry, but I remember carrots was like 12% yield improvement. That's one that stuck out. The number 6% stands out for tomatoes. But don't quote me on those. But there are a lot of papers that were done on all of this. Plus, one thing we didn't even mention here is the ability to add and precisely apply chemicals when you plant. Like if you want to apply a nutrient with that seed, you can apply it precisely right at the point of the seed. If you want to put biochar around there to prevent weed growth, fungicide, anything like that, the system allows you to pinpoint it right on where the seed went.
How many acres are they?
We're targeting right now with 1 unit, 10 acres a day, which doesn't sound like much. That's why the swarm is important. Didn't sound like much to me until I found out that a lot of fresh market tomatoes don't go out. They don't go out and plant 200 acres. They plant to rotate it through the market. So they're telling us we plant 20 or 30 acres this week, 20 or 30 acres next week.
Walter will be around. Well, we'll take one more. Go ahead when we sit down. I'll pull this up.
Get those seeds in the ground, and you can give an overview, or maybe I missed it, how does it dig a
You
hole?
need this.
Drop it in?
Well, and that's kind of proprietary at this point, okay, yeah. Sorry about that. But I will tell you, I mean, we're trying to, one of the things we try to do in our company is really, think it's a worn out phrase, out of the box. You know, the one I remember was we're not paving the cow path. We're looking at a new trail, you know. So if some things we do in agriculture are done that way because they've always been done that way, and they always done that way because we started off plowing with oxen, we don't think that way. We think clean slate, let's start over.
Walter, thank you. He should be around, so during the panel discussion, we can go a little bit deeper. So, up next is Jeremy Cromer. He's a principal scientist in the entomology department or division. And he's going to discuss how new discovery approaches can revolutionize small molecule innovation. Let me get you pulled up. Inco, right? If I didn't say that, he's with Inco. I'm sorry if I missed that. All right. Go, Jeremy. Thank you.
Sounds good.
If you need that.
Okay, so we're going to switch gears a little bit here, and I'm going to talk a little bit on how we're using AI and some of the new technologies out there to try to address the gaps that we have in active ingredients for crop protection moving forward in the years to come. A little bit of history about Enco. I've been with Enco for about a year now. In my preceding life, I was working in agrochemical discovery and biologics discovery for Monsanto Bayer for 9 years. At Enco, I came in to build the infrastructure for the entomology testing pipeline, and I'm also, since July, have been driving the biology function there. Our mission is to introduce novel product concepts, novel active ingredients, and new modes of action for the agricultural industry in an unprecedented speed and rate. The company was established by Jacqueline Hurd, Phil Austin, and Terra Capital back in 2019. Our headquarters are in Mystic, Connecticut. Currently, we have 50 people. We have this beautiful facility surrounded by protected land on 89 acres. It's a historic DeKalb Monsanto site. It spreads across 15.6 acres. And we're proponents of green energy. We've recently established all LED lighting in the facility, as well as state-of-the-art lighting infrastructure within our greenhouses out there that we're really excited about. Coming next year, we'll have a solar panel array in the backyard. Essentially, we're aiming for 10 million reduction in costs. So we're pretty proud of the incentives we're aiming for green campus moving forward. The company is basically startup, but with wheels under it. We have been recognized as an ag innovator, so the company's doing well. It's an exciting place to work right now, and we'll give you a little introduction into what we do and why we think it's important. This graph on the left is not a mystery to anyone in the ag industry. This is basically the new actives introduced, new modes of action introduced in the agricultural landscape over the last 30 years. There's a downward trend in active ingredients, but the need for those new actives has not gone away. If you look on the bottom left, the primary revenue sources remain molecules that were introduced prior to 2000. This is a big problem, because resistance is out there now, it's not going away, and it's only getting worse. What causes this in the left? Part of it is due to increased safety regulations, which are a good thing for the environment, but it introduces years into the pipeline, and that introduction introduces significant costs. So we've gone from 50 million back in the 1980s to over 300 million to introduce a new chemistry on the market by traditional means. All of this coupled with climate change, where you have new pests moving into new regions, fungal disease in new warmer climates. The need for this has not been any greater than it is now, and it's not going to decrease moving forward. Jacqueline describes our process as an intentional design, and that's because when we go about discovering new molecules, we look at what we're targeting first. So it's a target-based design. We identify the target, but before that, we identify the product concepts. Where are the biggest needs? Is it fall armyworm control? Is it Zyma control? And from there, we go about identifying basically the attributes of a new molecule moving forward that we want to look for. Safety, spectrum, selectivity, all of this gets engineered up front prior to identifying the best target for each particular product concept. Then we move into the actual screens and the precision design, and we incorporate a lot of the selectivity up front to try to improve the safety profile and avoid years of work on molecules that may not be suited for the environment moving forward. Ultimately, we want to develop these to product concepts at an unprecedented rate and bring them to market. To do this, the driving engine at Enco, we call it Encompass, and it's basically a combination of machine learning, artificial intelligence. The core is our Dell physical chemical library that goes into the screens. And we combine the learning from the AI and machine learning along with systems biology and structure-based design to understand and push these molecules forward. Starting with the target, we express those targets. Those targets are displayed on a Dell array. We flood our molecules over the array to identify unique binders. Everything else is washed off. So at the end of the day, we enrich molecules that are binding our target. We pull those off, synthesize them, and then we pull it into actual screens on the biology and the biochemical target. From there, our chemists take it and go into lead optimization. We may crystallize it to structure it to get a really refined approach and to lock and key mechanism on those targets. This is not an error-proof method, but when it works well, we've been able to demonstrate we can get hits in under 3 months. And we have one molecule that went from hit to lead in 12 months. And that's one furthest along in our development. As you can imagine, this lowers the cost hurdles for introduction of new leads by lowering the time it takes up front. It's very difficult to change. You may be able to reduce regulatory with a couple things, 1 to 2 years. But really what we can gain is an advantage up front, and that's what we're trying to do with these technologies. At the end of the day, we're aiming for hit generation in under 90,000 K or 90 K and hit to lead in under 250, which is unprecedented in the industry. So when you think about a Dell library, we're talking billions of chemistries. And how does that look? This is how it looks. So the problem isn't that we have molecules in there that will bind effectively our target and do what we want. The problem is, how do you get there? How do you find them? And that's what Encompass is all about. We use machine learning algorithms. We base our selections on what's known about existing agrochemical products. And we can hone in on the galaxies and the regions that are most suited for the product concepts we're looking for. We put those in our screen, and that's the starting point. On top of that, we can build into the screens other factors that are important for what we're looking for. If you look at the bottom left, if we're looking for competitive inhibitors to some known target sites that are out there, we'll put in a screen on the target without the inhibitor. We'll put in a screen with the inhibitor. Molecules that bind both are non-competitive. Molecules that only bind your target in the absence of inhibitors are potential displacement molecules or in the same location or pocket. When we do a selective screen, we put in a non-target. In the case of an insecticide, you'd think a monarch butterfly or a honeybee next to a corn rootworm. And we're looking for enhancement of molecules that are binding primarily to the rootworm and not to our non-targets. There's also the ability to address mutational resistance. You put in the resistant variant next to the desired variant, and at the end of the day, if you get molecules that bind both, those are enriched for us to take a look at as resistance breaking potential moving forward. Your DEL works like this on the top right. You have your mobilized target on the array. You flood it with your billions of molecules. They bind the pocket. At the end of that, you have a unique DNR barcode for each chemistry. Once you elute those, we sequence the whole batch. We get billions of reads off that batch, and that's where the machine learning comes in. We have to find a way to sort out all of that information into a usable form. So there's a big triage process internal to ANCO that goes on. We whittle that down to the primary targets from each cluster or each galaxy that we think is most relevant for moving forward with, order those molecules. Those molecules then enter your traditional pipelines for screening. On the top, you have chemists that are working for structure-activity relationships and optimization. We look at the biology, the translation from activity on the target to the biology on the animals or the organisms that we're aiming to address. At the same time, we're looking at non-target specificity, making sure that we are engineering the molecule to be something that's less selective moving forward. And this all leads to our lead generation and into our pipeline moving forward. You can see here, right now we have over 50 programs, and this is constantly growing. Those would be unique targets that we're engaged with looking at. The company proof of concept was based on a novel herbicide, so that we're most advanced in that category. Within the last 2 years, we've started to develop into the fungicide and insecticide space. My final slides will be an example of where we are with our most prominent herbicide class molecule. We have another in early development, 2 in optimization. We have a fungicide that's in the optimization process, as well as 2 insecticides. And in a lot of these, we have over 50 programs. About half of those are looking for resistance breaking or underutilized modes of action to identify new actives. These are the regulatory paths known, so a little easier path forward for those. About half of these are novel modes of action that have not been introduced into the industry as of today. So if you look, this is basically one primary example. This is the initial proof of concept for the whole technology. We were looking at PPO, protoporphyrin oxygenase. If you're not familiar with that enzyme, it's in the chloroplast. It's involved in generating the membranes for the chloroplast. So if you inhibit it, you break down the cell membranes, the cells die. It also is involved in chlorophyll production as well as heme production. So very proponent, a very strong enzyme in the herbicide pathway. 22 active ingredients on the market, well-established safety profile. The fact that the biggest resistance is a mutation here allowed us to put it in our DEL array and look for molecules that were resistance breaking. At the end of the day, we had 627 enriched profiles through the Encompass process, whittled that down to 50 chemistries, 15 of which that showed resistance breaking potential and a novel mode of action for this molecule. So the proof is in the visuals. You can see here. This is a glyphosate control. On the bottom is a field plot in Indiana. And the right is in Missouri. Looking at primary Palmer amaranth control, water hemp control. This does show pre-emergence as well as post-emergence activity. But most importantly, so our molecules are on top. You got a kilogram per hectare of glyphosate and nothing. We got 60 grams per hectare of our molecule that's competitive with a benchmark PPO that's showing resistance in the field, and we've been able to overcome that with this molecule. And this it kind of aims toward what we're aiming at. So lower cost of molecules, lower application per acre, and sustainability. We can't keep putting a kilogram of chemicals out on the fields and keep increasing that. It's just not sustainable moving forward. So that's the goal of the company. That's our aim. And it's not just in herbicides, but we're aiming for all the areas. And then this just shows the path forward for that molecule. We generated the hits. This all happened before I started at the company. From the initial hit molecule, 161 analogs in a few months, we got down to 1 ppm activity, additional 233 optimization, down to commercial levels of activity. And this is what has been advanced in over 200 field trials over the last 3 years. So the outlook for the company, we feel is looking very good and promising moving forward. We're not only looking at row crops. Row crops are a big industry, but it has, the technology is not built for row crops. It's built for identifying new actives across crop protection. So it's very applicable for veg control. It's very applicable for fruit. So, and we're always interested in new partnerships and in looking at new targets. With that, that's my last slide.
Have any questions?
So, do y'all plan to take products to the market, or are your clients going to be the current ag chem companies?
The company has been designed to go any direction. So we have a path forward, and we have a vision for that path forward to be independent moving forward. We have a path forward in case we tend towards acquisition in the future. We also have a path forward for public, going fully public. So it was built into the program. They've done a nice job of that. So we have an exit strategy for every direction. In terms of partnerships, we have active partnerships right now with Bayer, New Farm, Syngenta, and Bill and Melinda Gates Foundation.
Any other questions? If not, Chairman, thank you, and he'll be around for the panel. So, all right, we've got 2 more speakers up. I think Cole, is Cole here? I don't know if Cole made it. I don't think so, maybe not. So maybe we only got 1 more speaker. So if Cole Weber, one more time. I didn't think I seen him load the presentation. All right, Mark, you're up next. We got Mark DeRoche up, and Mark's going to discuss, he's with AirFX, he's the Chief Technology Officer, and he's going to discuss enlisting downwash to benefit aerial application. So I actually lied to y'all. We had two speakers that didn't make it. And so we'll go ahead and try the video one here and make sure it's embedded, but you know that you've got it back up in case it doesn't work. So, yep, that's it. All right, Mark, go for it.
Great. This is the.
Yep, that's it. It should be left and right, and then that is a pointer right there in the little red.
Which one do you think runs the video? We'll find out.
I will see. We'll test and figure it out.
So I'm in the aerotech industry in California, and I think we owe an apology to agriculture. There's never been a spray aircraft developed for ag. So let me show you what I mean. Everyone knows Wright Brothers, 1903, powered aircraft, first man to fly. And then 18 years later, this happens to be McCready. John McCready is an Army air pilot, and behind him is Charles Neely, who came up with the idea of crop dusting. And so they sprayed some catalpa trees with, you would know this, lead arsenate? It sounds brutal. Well, if you look really close, I swear that Charles Neely is smiling. And he should be. He's the first hopper operator in creating a whole new industry. So it's quite impressive. 25 years later, look at where we went. We went from no industry for aircraft to a Ford Trimotor carries 15 people and a crew. So aircraft, planes, were made for transportation. Then you got Sikorsky, 1939, develops the first commercial helicopter. And about 7 years, 7 years later, Herman Poland, he owned a crop dusting company in Yakima, Washington. They used planes. Larry Bell from Bell Helicopters in Texas approaches them and said, could you spray it with helicopters because the war ended and they had too many. They were looking for new industries. So he came up with, he then flew these through California for crop dusting. So in that 25-year span that Sikorsky developed the helicopter to 1964, you see that we have a huge, beautiful helicopter that's really made for lifting cargo and people. So now you look at the multicopter. I can't apologize for this one. It's not aerospace. But it came out originally in 1999, the first commercially available, and it was a toy. It came from a toy company in Canada, in Saskatchewan. And it didn't do very well until that same inventor, Zenon Dragon, came up with using it as a camera. And what he did was he blended the flight control system. Since a UAV is body steered, it's always moving. And so it's not a good camera platform. He coupled the two. So the gimbal counteracts the flight control system. So the two are coupled, and it makes a great sensor platform. So in 2015, DJI out of China introduced the first ag spraying drone, the Agris-1. And this is the first commercial spraying drone that came out. So this, you'd have to say this is the start of that industry. And then look, 25 years later, nothing changed. The reason is the multi-copter drones are designed to carry sensors. They're not made for spraying. They're great, they're amazing, but what's fascinating is the capabilities between that one, which was difficult to control, and this one are night and day. But the physical platform hasn't changed. You'll see later that there's a reason it hasn't changed, but I'll hold that back. So it's not that the aerospace industry has not been looking at the agriculture industry. As a matter of fact, they have since 1979. There's a company called CDI, they're in New Jersey. We've worked with them. They wrote a CFD program to track particles released by aircraft. It's quite impressive what they've done. And it's been validated and correlated since 1979 and improved. And we should pay attention to the results because the EPA uses it. That's how they use it to help set regulation. This is a picture of the flow field of a quad, a dual quad. So you see the four propellers and there's one under the other. It's kind of a typical configuration. And we've learned a lot from this. We use it for design. You guys can go online and get it. It's open source, or I should say it's public domain. We learned a lot from this for design. But what we learn from it operationally is really important. The first thing is the low release height really matters in a UAV. You got to be close to the ground. Second is the aircraft speed. It turns out you need to go slow, and this is contrary to how people want to operate them. And then the third thing is a low ambient wind. A crosswind will kick up drift, and the winds are much lower than we anticipated. And then it also introduced this concept of a critical speed when spraying, and this is kind of brilliant. And this was a big eye-opener for us. So I'm just trying to take that CFD output and put it into pictures to describe what's really going on. So the critical speed, it turns out, it's brilliant because it's a function of the downwash velocity. And like, who'd have thought those two are related? And then you think about it long enough in bed at night, and you realize, oh, those two are related, of course. And so the downwash velocity is really easy to calculate. So if you know that, the model tells us that you can't fly anywhere close to the critical speed. You have to be at least 80% below it. Well, the critical speed for a drone is 12 miles an hour. So 80% below that is 10. But a drone with 50% payload and 50% structure. So by the time you're finished flying, you've dumped your payload, or I'm sorry, halfway through, your critical speed has dropped down to around 8 or 6. You got to, you have to reduce your speed as you fly. And so that right now is a pretty easy algorithm to put in a flight control system, but it's something you have to be aware of because when an operator really just wants to cover ground and get to the next farm, you really have to watch what the spray speed is that they're flying at because it really speaks to the efficacy of your application, and you're paying for it. So the another thing is if you pass the critical speed, this is what happens. You kind of outrun your downwash. So what's happening here is you're getting in front of your downwash is pushing down, you're flying in front of it, and now it is turning around, going under and picking up your spray, right? And so that's not good. That just puts it up into the wind. It's either going to evaporate or drift off target. And so at the third point here, after translational lift, a plane, by the way, is always in translational lift. And what translational lift looks like is if you're in a helicopter and you push forward, your nose forward, you're hovering your nose forward, and the thing will drop a little bit, and as soon as you get to 15 knots, it just takes off on you. It just goes. And what you've done is you've hit this point where the blades are flying through the air edgewise, just like a plane. And it's really potent, a lot more power. And so a drone operator wants to operate in that range because what that does for him is it saves batteries. Hovering takes a lot of power. Get into this range, and you can go probably another maybe 50% more on your battery life. The problem with that is, of course, again, you're paying for it to hit your crop, and it's not going to go there. So that translational lift is something you definitely want to stay away from. You see the result right here. But then when you get into what you call aircraft lift, wing lift, you still have, the pilot sees 4,000 pounds of downdraft lifting up the plane in the pesticide, but the corn doesn't. The corn actually sees 1 unit of time of that plane passing by it. So you need to integrate over the area and the time. And you can see there's very, very little downwash. It's not even noticeable. It's not even pushing the input down into it. So it's relying on gravity here. But it's a beautiful, beautiful uniform flow. It's kind of what you want. So with drones, you can see that's not what you get. So this again comes out of the CFD program, and which is validated and correlated in the field through studies with the Spray Drift Task Force. Okay, so these two pictures are not to misrepresent. I don't want to misrepresent these aircraft. They're great. They do their job well, but the EPA is responsible for labeling pesticides. If they approve them for aerial application, generally this is what the note says. Don't apply at speeds, ambient winds in excess of 15 miles an hour. That's kind of self-explanatory. It's just trying to keep drift down. And then greater than 10 miles an hour, the boom length must be 65% of the wingspan. You can see what happens in that picture. That's 100% of the wingspan. And the drift just gets pulled back up by the wingtip vortices. Same thing then for a helicopter, it should be 75% of the rotor diameter. Here's one 100%, same thing happens. You can see why they dictate that. And then less than 10 miles an hour, they give you a little bit more boom length. Because that, again, is your swath length, and that's going to be how long you stay over the field. So there's a lot of energy goes into a small boom length versus a larger one. So 2 wingtips, 4 wingtips, and then you have a drone with 8 wingtips. I mean, something's going to go south here. And so the way it works right now is the drone industry, spraying industry has gone ahead of the EPA. There's the task force, it's the Spray Drift Task Force is trying to keep up. But what they've done, there's preliminary ruling, is that they're going to allow anything that can be sprayed by air to be able to be sprayed by a drone, but there's no other guidance. So the label says nothing more than aerial application. For an aircraft, for an airplane, you do this. For a helicopter, you do that. So what does that tell the drone operator to do? Not a whole lot different. So what's happened is you saw from this chart here that they're allowing you to go to speeds in excess of 15 miles an hour. Well, if you do that with a drone, you're past the critical speed, but it's legal. And so you're kicking up that drift. The rule needs to be changed or looked at. It says also that you can fly in winds up to the ambient wind up to 10 miles an hour. We're showing that there's issues with that. And then they're specifying boom length, but most drones are going to the boomless scenario, where they're just spraying under the back two rotors. It seems to keep drift down, but you can see it doesn't make it uniform. Right under, it's two jets. On the sides and in the middle, it's a little less, so those plants suffer. And then, of course, you see in the corners, it's getting caught up outside of the downdraft, and so it's kicking up. So that's not good. Everything in quotations, by the way, those are my words. They're referenced in the back. They're coming out of academia, and a bunch of papers back there are listed. It's worth looking at. So drones, these drones, this is according to the Ohio State University, these drones will probably be banned. And so if you own one, or you're a manufacturer, or you operate one, excuse me, the manufacturers are probably making retrofit kits if they're aware of the upcoming ban, because you can just see what happens. It just doesn't work. You really can't get past the wingtips. And the problem is, with so many rotor tips, you're crossing the boom always with four tips in opposite directions. So you're really just creating swirl. Okay, so if you were to create the ideal spray platform, first and foremost, you go ahead and leverage the advantages of the drone technology, right? The drones are great. They're highly capable. Their performance is fantastic, not for spraying, but for doing so many other things like precise positioning, collision avoidance. You have an intuitive interface. They can do seek and spray. The next thing they do is, of course, they get rid of the pilot, which is wonderful for a weight perspective. You can now use that for payload. At the top, the first thing you do is you get rid of the rotor tips, and you get rid of edgewise flight. You don't allow it to fly in translational flight. And you maximize the lift within a given diameter. And that's not hard to do. We already do that in aerospace with ducted fans. And it's just a fan inside a shroud. At my company, we work with these a lot, and this is an example of a high aspect ratio one. And then I mentioned the critical speed is a function of the downwash, and the downwash is a function of the weight in the area. And so it's that simple. So you want to get the heaviest payload possible, make it as big as you can, and only use 2, not 4. Just control it with 2, because you get the smaller footprint, the smaller area, and it's easier to trailer. So those 2 keys kind of put you in this direction, and then you use the drone technology again to fly in either direction. So for row crops, you really want a large width. These are our vehicles right now are about 10 feet across, and you really want to expose all of that to what you're spraying. It's just a large spray boom, and we can get away with a boom on ours because we don't have any wingtip vortices. And then for orchards, it's a little bit different. We have a different boom up front, and you really want to penetrate the canopy. You want to open up an almond tree so you can put the input right into the top of the canopy. And so, again, we couldn't do this with a man. It would be pretty difficult at 2 flying orientations, but with a drone, with drone technology, it doesn't really matter. And so this is the way we've approached what we think is the ideal platform for spraying. Okay, so this will be the test. So this is we've flown a 250-pound version. That's this one. It's about probably 8 feet across. We've been flying a 350-pound version. We are right now finishing up and starting a flight campaign on a 400-pound version, and then when we launch, it'll be a 450, 25-gallon version. But what this is, it just shows what you can do if your intent is to do it, to manipulate downwash. So right now, this is that 250-pounder. We've converted into a test bed. What you see, the first video, the props spin at 4,000 RPM, and they don't look like they're turning in this videos. And the first part is we take these ducts off. You see these ducts. We take them off. So it's just an open rotor, and then we put these smoke signals flares right at the worst place, at the tips. And if you imagine, if you're going to come at you, if you're spraying a field, you have that smoke all the way across on a bar. But in this case, smoke really has very little density, so it's like the smallest droplet you can imagine. So it exaggerates the problem, which is what we're looking for. And then when the second clip, we go ahead and put the ducts on, and you can just see the difference. It actually works.
There we go.
That's amazing.
Hey, you did it right.
All right, so this is what the ducks off, and this is just typical, just like you saw the wingtip vortices from the other aircraft. And look at the background; everything's just getting thrown up in the air. It's kind of getting, the skies are getting dark, and this is just a side view of the same thing. And then here we put those ducks around it. And you can see now, this wouldn't normally be there. This would be in the canopy, but we're over asphalt. But you can see how you can tailor it to really the effect you want. It's just not difficult as long as that's your intent, and that's the side view there. All right, so the reason we're doing this is I saw a bunch of charts here already today, and everyone faces the same problems as growers, and it's pretty global. I mean, the aging workforce, lack of labor, and really the expenses associated with running a farm. And the unmanned technology has been proven, it's gained market acceptance. In Japan, they had a program started in the 90s, about 92, and they had all those same issues, but they also had urban encroachment, where the towns were moving out into the farmlands, and so they were using big helicopters, manned helicopters at the time, and that was that noise was no longer tenable. So what they did was they started a program. They worked with industry, and they worked with this is the government now, and then they worked with not only the farmers but also with the residents. And they came up with the RC helicopters. They carry about 15 gallons, and they started replacing their manned helicopters using this for spraying. You can see this was all before drone technology. They put 2,000 of these things in the field at $150,000 a piece before they even had the technology that we have today. They made everything themselves. They were flying them manually with an RC, just like you would do with a hobby plane for quite a while before they started automating it with drone technology. But so today, 40% of the rice paddies are treated with these things. 3,500 of them are currently operating. They brought this to the U.S., I think it was 2012 or 15, and it got no traction. And there's probably a big reason. It's made for 7.7 acres. It's perfect for 7.7 acres because that's what they're designing for. That's 1/60th of our farm size. And it's just not applicable. And so, but it worked in Japan. It was accepted. They're still operating. Very similar in China. China has 150,000 spraying multicopters. They're the ones who invented it, the whole business. These things are small. They're 10 gallons at most. That's the biggest. And of all the ones that are fielded in operation, $3 billion in retail is about what they've established since 2015. That's pretty good. The average farm size is 1.6 acres. So you have to have 278 farms to make it one U.S. farm. And so it's easy to argue that that product is really not for the U.S. market. There's another issue with the product, and a lot of venture money has gone towards proving it, is that they don't scale. A multi-copter drone has competing constraints, so you can't make them big. If you remember the aircraft that went from one man to 15 people in 25 years, a drone, this now is 25 years old. The biggest thing we have here is 2 people. It comes out of China, and it's for joyrides. You can buy a single person one, but it's a kit. What happened to 25 people? It doesn't scale in the market. The market kind of proves it. Technically, it's easy to prove. Matter of fact, in the back, there's an article from Wikipedia, a link that tells you why. Anyway, so we're doing it because we think that the drones will predominate in the U.S., but just not the platform that we're seeing today. And that's kind of our driver. Okay, so I think the important thing is that every grower in this room collectively is the biggest sector in the world, financial sector in the world. I mean, I thought energy was until I looked it up, and it turns out agriculture is the biggest. So if you pool your buying power, you'll get what you want. I really encourage you to press regulators. We have the EPA, FAA, and your state regulations are what permits you or don't allow you to spray with a drone. And you can get involved at any level. And even if you're against spraying with drones, get involved and put that in there, because if you don't, it's going to be the ag chem manufacturers or the ag chem producers or the drone manufacturers that dictate what you get, and that generally means the grower holds the liability. It's what you're seeing right now. If the operator is going too fast and creating drift, it's your problem, both because you lost the money, but it's your liability. And then also the labeling. We really need faster labeling so that people can react to these new technologies, and that's all EPA. And I understand their conservatism, but I think they probably could do better. So then specifically from the manufacturers, if you're hiring someone to spray your drone or you have one, be sure they're using on-label mix ratios and rates, because most aren't. You're not going to get the coverage they advertise with using the mixture rates that the EPA requires from the label. Are they spraying below the critical velocities, and at what altitude? And again, the altitude is important. They're incentivized to go high for a large swath width, but that's not in your best interest. And then, is there a vehicle model in AgDisc? So we use it for design. You can pay Continuum Dynamics to put it in there for a fraction of the cost you guys spend to buy one. So if they're a valid manufacturer, their vehicle should be in there. And then you can see beforehand what is the critical speed, how fast should it go, how low should it fly. And then, again, if it has a spray bar and you own one, the manufacturer's probably already working on a replacement, a boombus replacement. And then, we're in California. We use the Salinas Valley, San Joaquin Valley, and Sacramento Valley as test sites. But we're always looking for comment from anybody who owns a drone or operates a drone, always from growers, and we're always looking for something new to fly over. So if we can get vehicles out here, it's not like Georgia and California are across border. So you contact us. This is the list I mentioned of really great resources, and then at the end there, get a hold of us and let us know your complaints or concerns.
Any questions for Mark?
Yes, sir.
Have you looked at how to power your drone that you're working on?
Yeah, so because we're not, because of this configuration here, we fly with a single motor. We're not dependent on using motor torque for control. And so we can use a single motor, which means we can use any motor. So we right now burn petrol. And we can use a hybrid, or we can use all electric. It doesn't really matter. We use petrol because, honestly, it's what the farmers want. But we are going to launch an electric version as well. But I think the best route for us would be a hybrid, where you could perhaps go quiet when you're close to a residential area, or go long when you just by burning petrol. But doing both in the same mission might be really helpful. Yes?
What do you envision the maximum payload to be?
Yeah, so we don't really want to compete with drones. Our restriction, we were talking about this morning, is this width right here is we're set by the width of the street, which is about 8 feet 4 inches. And at that, with enough horsepower, we can compete with a plane. So ultimately, we're looking at the end game, and we're really at the infant stage of a new way of spraying. And we're not trying to say, okay, how can we sell drones tomorrow? We're looking at where we're going to be in 20 years. And that's the technology we're trying to make today. I don't think you fly helicopters or planes in 20 years just with a man on it to spray crops. Anybody else? Thank you.
All right. Thanks, Mark. All right, so that concludes. Oh, here are your glasses too.
Oh, yeah.
That concludes our formal presentation time period for this. So